Frank or JB, can you sort out the chat if we're discussing or need to sort out any questions? I'm going to be 10:15. I just want to go on a little bit about legal and contracts, and then I'm going to have a quick chat about a personal instance where I've got some contour surveying for a development application that I've put in, and it's pretty current and it's a little bit valuable for you, so I might go for about 10-20 minutes with it. All right, firstly, some of you may have already just received a message. It's for student summary. Does everyone remember legal? I'm going to close the cluster this week. Frank and Adrian and Glenn have been doing a brilliant job marking, and I think everything's up to date. Could you just make sure you go back and check yourselves? Make sure you're happy with your marks, okay? And if you have any issues, please contact the assessor who's been marking them, because some guys sort of miss and don't realise. Then could you go to your student summary? Can you see that student summary there? And we need you to answer the questions. Now I'm just going to put up the questions. You can see, I know it's in the teacher format, but you can see it's just checking that you've passed everything. So assessment 1, assessment 2, 3. Okay. Could you just confirm that? Give us the tick box, yes or no, so we're aware that you understand you failed or passed. It's not wasn't the hardest subject. It was probably a little bit long-winded, but at any rate, it's something that needs to be taught. And I'm glad you've got that background. There are 47 of you that haven't completed. Oh, it's 40 now. There you go. So could you please get that sorted for us? All right. I am going to close the cluster at the end of the week. All right. Okay. I'm going to get a wriggle on. All right. The reason why I wanted to show this, I'll actually quickly just show Glenn. I said this might be a good example to let you understand the reason why you're doing rise and fall and height of collimation. Like sometimes it is a surveying task, and I know it's probably a little bit old school, but it sort of reflects on how you work out your heights. And this is something that I would do on site immediately once I would get the machine, and I have to get the heights for footings and so forth. So before you start on any job, I've had to go get my DA approved, so I had to go get some drawings. That's a picture of my house in Gerringong. I'm actually going to subdivide it. I was going to do it this year, but I think I'm a couple of years away. I've got no money. Anyway, so firstly, I contacted a building designer or a arc draftsman, pretty good company. And the first step was actually to get a contour survey made up. You can see, if I go back, you can see the actual job is on a real slope. It's a bit of a shocker to build on. You can see there's 3 meters from the garage up to the bloody doorway. So there's a massive slope. Okay. So what we did was, we've got a surveyor who come out on site and he surveyed the land. Okay. Can everyone hear me all right? There's a few questions that I'm not sort of focusing on. Now, if you can see nice and close, it's giving you the heights. You know, we've got 18 metres of contour running across the retaining wall. It goes quite steep up there. We've got a deck. That's the existing house. They even give you the RL of the building ridge, which is obviously at the top of the house. We're having our retaining walls out the back. I've got a deck with the heights. So it goes from, we've got 18.9 here all the way up to 26. So it's a steep block. It's bloody horrible, but anyway. That firstly goes to the designer, and he puts that into his Revit or ArchiCAD or AutoCAD. Okay. Now, can anyone see this? BM. Everyone understand what BM stands for? Benchmark. Yes. Top of curb. We have a reduced level of 18.318. AHDs. Everyone understand what AHD is? We spoke about it. I just want you to remember. Can someone tell me in the chat box? Sam, you're all over it. All right. So that's on the top of curb. There's a little cutout and a little pin showing. So that's what we work to. So the whole job is reflective of that, right? So when they go to design, you can see before they demolish everything, they've designed the building as it is, worked out the contours, and everything pretty much works off that benchmark. Yeah? Has anyone ever done that on site? Worked out benchmarks, reduced levels on site? As a site foreman, I used to do it all the time. You can see that's the finished job or the future job. This development application has been approved. You can see on the left, it's still reflective of that benchmark. Everything works off that. Okay? So before and after, working as per the benchmark. All right? And you can see there is my finished, or hopefully finished project, which hopefully I might do in a couple of years, I hope. At any rate, the actual way they design it is they work off the contours first. So when they get their Revit program, they put it in and then they start building the job. And he said it's actually easier when it's got, because that, see that actual plot there, that's the existing line of the old building. So we've just followed that, if you can sort of see it there. So it's sort of the old building and it's just fine. I'll just put a second extension on. So that puts it in a bit of a 3D perspective. And then you can see the existing ground line and you can see natural ground line and finished floor level, how it's adapted to suit. All right. And now that's a hard job, isn't it? Well, I think it's bloody hard. That's the east elevation. We've got the west elevation. Okay. Now what I want to talk about is these RLs. So as a builder, you need to get these RLs pretty spot on, don't you? You don't want to be out. So as soon as you get the benchmark, as soon as the surveyor gives you the benchmark, you got to start, pull out your dumpy, get your machine in, and you got to plus and minus, really, don't you? What do I mean by that? I mean by, for example, we're going to obviously get the machine in and start with the garage first, aren't we? So see the finished floor level, 18.808. What was the benchmark? I think it was like 300 or 400 less or something, I think, off memory. And then it goes up 4 meters to the first floor, so it's quite a steep block. So it's going to be quite hard to get it right. I would probably on this job have the benchmark at the top of curb, and I'd probably get them to give me another benchmark up top somewhere. Might cost you an extra $300-400, but it'd be a lot more accurate. Some builders might just use that. That's fine. They'd be confident with themselves, but I'd be probably inclined to get another benchmark or datum to work off. All right. This is actually, it might be a little bit hard to understand, but I'm going to put a forum up. I'm going to get you to answer it. Now, obviously the answer is going to be there, but I want you to understand or have a think. The builder has to set up an automatic laser level, or dumpy, whatever, to begin excavation. I want you to calculate the following. So firstly, grab your calculators or your phones. What is the HOC? Or the reduced level instrument height if, so we go to set it up, right? It's 2.090 reading from the benchmark. Can someone tell me in the chat box? Let's do this one first. What is the HOC? Well, I've called it height of collimation. When I actually start a job, every job I've ever run as a foreman or site manager, I got this book, A4 book, and my front page has always got the benchmark and the excavation lines, because that's obviously where you start. It's every time I've always got it. So benchmark is 18.318. Geez, I hope I've done my maths right. You're making me nervous, Adrian. Sorry? The bar. What is the instrument height? All right, well done. 20.408. Does that make sense? Now see that little crappy little diagram? Does that make more sense? Yeah? That's the height of my instrument. So my reduced level as of that instrument is 20.48. That's something I would do on site. That'd be the first thing. Right, what's the height of my instrument? That's where I work everything. Now you've got the machine in. What should the reading be on the staff to confirm correct height of the garage FFL? Let me go back. The garage, sorry, I can't talk properly. FFL is 18.523. Now, the garage hasn't been built yet. We've demolished everything. How do I know I've got to get to that finished floor level? I have a instrument height of 20.408. I'll go back to the question. 1.885. What should the reading be on the staff to confirm correct height of garage FFL? Okay. Does that make sense? That's a little picture. I would have that on the first page if I was a site foreman or builder on a job, working to that reduced level. I'm not sure if apologies for those that use this all the time. All right, next question. What should the reading be on the staff to confirm the correct height of footing, 400 mil depth below the FFL, all right? Thank you, Alan. What should the reading be on the staff to confirm the correct height of footing, 400 mil depth below garage FFL? 2285 is what you would have your staff. You'd have your labourer walking around on the staff, and he'd be going, the laser's like it's 20 mil too high. You said the machine's got to go down lower. You never do it low enough, do you? You always go, oh, that should be enough, and you check it, nah, it's got to go another 50, 100 mil. Your reduced level would be 18.123. That's the underside of your footing. Does that make sense? I'm going to put that up for you to have a look at. I was going to do a quick quiz, but I ran out of time, so apologies. I'll probably do one for tomorrow or Thursday. But that's like in its simplest form, a height of collimation or your instrument height that you work off. That's what I would do on site. All right. Happy days. Any questions? I'm going to hand over to Gleno. And I'm going to put that up for you. What I want you to do is there's a forum asking you to put the answer in. So the answers are there, but I just want you to put it in so I know he's actually looking at it. All right. I'll hand over to Gleno. Thanks, everyone.
Okay, hi everyone. I hope that helps. It sort of links the surveying, the contour heights, the height of the land with your floor levels, and it's a current job. So look, what we'll do, everything that we've done so far, you're going to get assessed on your field day. All these contour plans, how you calculate the distance from the highest grid point using that little arrow. You have to do all this on your field day. Okay, we've got one more item that we have to have a look at, and what it is, it's changes longitudinal try and get your
Papa? The audio sometimes might be good, sometimes might be shit.
You want to make sure the microphone is on so everybody can hear you.
Righto, can you hear me? Righto.
All right, plan B. All right, look, I was just saying you've got one more thing to learn before your field day. We're going to go through that tonight. Now, I'll just open the document up to start with and just give you a little bit of an idea on what it is. Okay, so what it is, you've got to plot a drainage line. Okay, so what we're doing, we're taking readings every 2 meters along a line. We have a look at this here. You're taking readings at 2 meter intervals along a center line of a proposed drainage line. It tells you the width of the trench. It tells you the minimum depth of the trench. Okay, you've got to have a minimum amount of cover for some drainage lines. It gives you a design RL, and what that would be a pit. So the first pit would be at 99.25. Okay, the second pit, and it could be a pit, is at 100.150. So if we looked at that, what's the difference in depth? It's 900 mil. Okay, so you've got a 900 mil difference. So there's 900 mil fall in that pipe over 10 meters. Okay, so what we've got to do, or what you've got to do, we're going to calculate the grade. We're going to draw it, and we'll just go down here and have a look. Okay, so virtually how it starts off. Yeah, how it starts off is the same as what you've done. This is just an example. Okay, so we've got readings here. So if we look in the middle here, we've got our readings recorded. 2 meters and 90 is a benchmark. Then we've got readings here of 1880, 1670, 1430, 1240. Okay, so everyone's familiar with how to enter that information over here. The first reading's our backside. Okay, the next one's our intermediate sides, and the last one's our foresight. There's our 1 meter and 90. So this is exactly what you've been doing throughout this last month. Okay, we then do our RLs, and this RL here, it could have been 20, could have been 30. We always pick a nice easy number because it makes your calculations that little bit easier. That's the only reason that number 100's picked. It's just for an easy calculation. So when we do this height of collimation, it's 102 minus our 1880. That gives us that height there. Okay, and we just progress through down there. We do our checks the same. Back sides, four sides, we get a meter. First RL, last RL, we get a meter. That's the important part, to make sure that you your booking sheet's balanced. Now, okay, what we do when we transfer these these readings here. The best way to show this. Okay, so we're going to transfer this reading. I'll just make this a little bit smaller. Can everyone still see that? Okay, so what we're doing, this RL here of 100 is our first RL down here at 100. Okay, the next reading at the 2 meter mark. So this grid is 0, which is where this 100 RL is. That's at 0. Then we've got 2 meters, 4 meters on that line there, 6 meters on that line there, 8 meters on that line there, 10 meters on that line there. Okay. All right. So what we do then, we then transfer these RLs down there. So we've got the 100, 100.210, 100.410, and they're where they are at 2, 4, 6, 8, and 10. We're just putting those readings in here on this line here. Okay, all the way across there. So they're just the RLs from that small height of collimation booking sheet. All right. Then what we do, we've got a design RL. Now what the design RL is, if I Glenn, can you open them up for us? Okay, all right, fair enough. I'll open it up so you can actually have it. Okay, so just hang on a sec because it's just opening. If you want to get that up on your screen, it's shown now. Okay, so, all right, so we've taken the RLs from here and we've entered those in from here. Okay, the next step we have is the design RL. And what the design RL is, that that's the height of the pit. Okay, that could be the height of the pit. Okay, so the pit is at 700, a depth of 750 mil. Okay, at 0. So that's our pit there. Now we have another pit at the other end, and it's at 100.15. Okay, so in between these two pits, this is exactly what we've got here, 100. Our two design RLs, which we went up here, which was 99.25 and 100.15. So that's 99.25 and 100.15. Now, how we arrived at that, we've got to actually we've got to get a line somewhere to get our measurements off. So this RL of 100 has just been put in there. Okay, it was put in there. Now what happens with that, if we look at the, just got to get my calculator out of the bag. Or is it over there? It's not over there. Okay, so we've got 150. So what we do, it's got a scale, it's got a vertical scale of 25. So we've got to go up there from this 100 millimeter this 100 RL, we've got to go up there 150 mil. So if you go 0.15 divided by 25, that equals 6 millimeters. So what happens with that, if we go to this, so I right clicked, I go to format, I go down here, this is in centimeters, so I want to go to 6. So what happens, that's my scaled arrow to the height. So what I do, I put it on that 100 millimeter, that 100 RL. I've got 150 mil higher than that 100 RL. I've scaled it using that 1 in 25 vertical scale. And then that's where my RL is there. Okay, so that's my design RL. That's my grid point. That's my point for this pit. Now what would happen down here, this is below that 100 RL, this is 750. So if I got the calculator and I put 0.75 divided by 25, it's 0.3. So that's 3 centimeters. So what I do, I right click on the arrow, I go up here and I put 3 centimeters there. I drag it over to the 100 millimeter line, and that's where that would be in that spot at the bottom of that line. Now, does that make sense? So what we've done, we've put the two pits in the correct spot. Okay. So that's my design RL there. Design 2 as per specification. There's my design 1, and this RL of 100 has just been put in there so that we can measure up and down from it. We measured up to 100.15 and we measured down to 99.25. Okay, so that's our two design RLs. Okay, then what happens? We've got a design RL to start with. We've got a surface RL, which is 100, which is right there. And below that is the bottom of our trench, 99.25. Now what happens is we've got a, if this is our, not if it is, we put our drainage line through there. Now, that would be our drainage line. It goes from point to point. Right? Now, what happens? It has a rise every 2 meters, and it's a consistent rise every 2 meters. So we've got to do a calculation for that. Okay. Now, where that calculation is is here. What we've got to take the 100.150 minus 99.25, and then we divide it by 5 because there's 5 grid points. 1, 2, 3, 5. So we divide it by 5, and that gives us 180 mil. So from here, just delete that. What there is, there's a film that actually accompanies this. And what happens if you get stuck? Help. Okay. If we add on 180 mil onto 99.25, we get 99.43. Okay. If we add on 180 mil, which was the calculation we did down here, we then get the 99.610. Then the next 180 mil, so it's a consistent rise. That pipe goes through in one grade. It's not in 2 different grades, it's in one grade. So, okay, so our design RL ends up being right, okay, because we've got 100.15 and we ended up, when we added on our 180 mil per 2 meters, we got to 100.15. Now, the next step you have to do is you've got to calculate the depth of the excavation. So if we look at the depth of the excavation, how we get that, it's 100 minus our 99.25 gives us 750 mil. 100.210 minus 99.430 gives us 780 mil of depth. That's how deep our trench is. Then we've got 100.42 minus 99.16. It's 810 mil deep. The same here. We just do these calculations. 810 mil deep, 880 mil deep, 850 mil deep. All right. Look, then what happens with this? We'll come back to this in a sec. Because you've already done how to calculate an angle, you've completed how to calculate a ratio, you've done the calculations to calculate the percentage. So on this RL here, we would have, okay, in calculating the angle, it's height divided by length, and then we do that shift tan. and we put our decimal place there. So in this instance, we've got 100.15 minus 99.25 gives us a height of 99 of 0.9. Okay, we divide that by 10 because it's over 10 meters. That's the distance. And when we have shift tan, we go shift tan 0.090 and we get 5.4 degrees, which we've already done. Okay, so we've got to do the angle, the ratio, and the percentage. Okay, and this is just an example of it. Okay, now the other thing is once you've got all these points in the right place, which we do with that arrow. These, as I said, this one here is 420 above the 100. So it'd be 420 divided by 25. And that would, 400 divided by 25. That would give us 1.6. So what we would do, we would right click this and format 6. So, and that would be your grid point there. Like I said, it's not a bit of architrave. If it's a little bit higher or a little bit lower, as long as it's pretty close. So when all those points have been put in, you then have to insert your line, which goes like I said, it's not a bit of architrave or anything. So there you go, and that's the slope of your, that's the contour of the land, that line that we just put in. There's our 2 pits, and that's our drainage line. Okay. Now, what else you have to do is calculate the depth of the trench. And look, rather than going in too much with that, what it is, you've got to add up the 750, 780, 810, 810. So if you look here, it's 750, 780, 810, 810, 880, and 850. You add up all those figures, you get a total, and then you've got to divide it by the number of points. And there's 1, 2, 3, 4, 5, 6. Beg your pardon, the 6. Okay, so we get the average. It's divided by 6, gives us an average depth of 813. 813 mil. Okay, 0.813 meters. Look, I know it's pretty difficult. I'll just miniaturize this a bit. There's 2 films here. Now, I broke it up into 2 sections. Don't break off yet, because what I'll do, I'll mute the sound. Okay, all I want to do is just show you. This goes through the steps on what I've just gone through there. Okay, if I accelerate this, this is just showing you to start with that you fill that in. It then goes through how to calculate the design RL, because it's pretty hard to stand here and explain it without a whiteboard. But you can use this as a reference if you get stuck when you're filling it out. Okay, so that's part 1. That does the bottom part of the document. Okay, now if I close that, we're not going to watch the film. I'll leave that up to you. Some of you will just go straight ahead and be fine with this. Others might struggle a little bit. Okay, the second part is, this is the second film, and we won't listen to this either, but this is the second part, and it's going through, it goes through the steps on how you do the calculations, where the calculations come on the bottom there. Okay, so if you get stuck, you need a reference point. If you need to know how to get the vertical height, it's all in these 2 films. All right. Now, I'll just miniaturize, or I'll just reduce that. All right, so what I'll do with those two films, I'll just put them up. Put the other one up as well. Now, just before we go any further, I'll just go through one more thing, and this is, okay, this is a hand-drawn pipe section through a pipe excavation. Okay, it's pretty much exactly the same. I think because of the tabs that we've been having to give you a height and then using the arrow to calculate the distance, I don't think anyone will really need it. This still has the service RL, the design RL, depth of excavation and change, which is just the distance. All right, what I'll do with this now, I'll just open some of there's two calculations that you have to do, two exercises that you have to do. Now, one of the things that's been happening probably in the last couple of weeks is your worksheets. No one's actually uploading, or not many students are completing the exercises. There's only maybe still 60 to 80 completing the exercises, so we're still well short on how many people should be completing it. And you've got to upload your, if you want feedback, you've got to upload your work, because we can't guess where you're wrong. Okay. The first one, the first exercise that you have to do, pipeline readings and excavation 2's up now. You can actually open it up and get started on that. There's a quiz that if you can complete the worksheet first and then answer the quiz from your workings on your worksheet. And then what you do, you've then got to upload. You've then got to upload the document. Okay, upload your worksheet. So there's two activities. Look, that is probably it for the learning material. So I'll stop the recording because a lot of the work is done by you.